Hello everyone, my name is Tifara Mandela Julius and my metric number is 821AC4060. We are from Group 3 Operating System Section 2 and our members are me, Fatan Rasul Muhammad, Faizai Mania Putri, and Kamasai Siddiqui. Now we'll take this opportunity to present our project about a book lending system and book allocation or availability system. For our project, we chose number 6, which is Resource Allocation Graph, RAG, and Deadlock Avoidance Safety Algorithm. We chose to implement the RAG using animation and programming code for the safety algorithm. Now I'll explain the RAG implementation first before going to the safety algorithm part. So for the RAG, we took two conditions using the book lending system, one with deadlock and the other without deadlock. In the graph I'll be showing now, there are a total of 4 processes and 2 resources, with each resource being able to be lent by 2 processes. For the implementation, we have customers as the processes, C1 for customer 1, C2 customer 2, C3 customer 3, C4 customer 4. And for the resources, there are 2, B1 for group 1, B2 for group 2. Here are the processes and instances. Let's see the relations. So the request arrows represents a customer requesting to borrow a book, while the hold arrow represents that the book is being lent to a customer. So from this graph, at first sight, it may look like this graph has a cycle that may involve circular weight, but let me explain further why it has no deadlock. So the scenario goes like this. Each of the books have 2 copies, and both of which are being held by customers 1, 2, 3, and 4. Even though customer 1 is requesting to borrow book 1, which is being lent to customer 2, and customer 3 is requesting to borrow book 2, which is being lent to customer 4, there will be no circular weight because customer 2 is not requesting to borrow another book, and so is customer 4. So as soon as they finish borrowing the book, the copy that they were borrowing will be lent to customers 1 and customers 3 who are requesting to borrow it. This happens because the process is only holding the resource until it has finished its process. As long as they're done, they will release the resource and the other processes requesting for it may hold them. This is why there will be no deadlock. Next, for the deadlock RAG will be explained by Philip.
Okay, hello everyone. My name is Masai Sidik and my level number is 811EC4057. And as my previous teammates said that I would like to explain about deadlock resource allocation graph. So what's the difference between us between deadlock and non-deadlock RAG? So let's take a look to our graph. So we have process which represented by customer 1 and customer 2 as well, and the resources by book 2 and book 1. And this is our graph, C1, C2, B1, B2, but there is a circulation weight, I mean. And then we also have a hold arrows, request arrows. This is what I mean by circular weight. So what's the difference? The customer 1 is already bought or borrowed the book 2, but at the same time, the customer 1 also want to borrow book 1. But meanwhile, the customer 2 is still borrow the book 1. This is the deadlock session in the resource allocation graph. So the difference between this one and the previous one is each of books have only 1 copy. So that's why if the customer 1 want to lend a book, meanwhile the customer 2 also borrow the same book at the same time, so it cannot be happen. So that's why we call it deadlock resource allocation graph. So this is about the deadlock RAG from me, Mas Sudik. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Faiza Imania Putri, metric number 81EC4044. So in this occasion, I would like to explain the implementation of programming of availability book system. And we use C++ to make the algorithm here. And firstly, in the process class, it holds the information about the need, maximum, and allocation of the book. Also, it computes the needs here. While in resource manager, it contains 4 methods. First, add process method, it's proposed to add new process to the system by specific allocation and maximum. And then next, in allocate resources method, it checks if the request can be satisfied or not by checking that it shouldn't be exceed the process need or available. And if it's exceed, it will show this message request exceeds the process need. And if it's not enough, it will show this message not enough resources available. And then in the next method, it called is safe state method. So it will check the system is in safe state after allocation or not. And it contains algorithm to ensure no deadlock occur. Next is safe state method. It contains the core algorithm to ensure no deadlock occur, and it will here iterate all the process to check if all processes can finish, and it will add it back to available if it's finished, available or work, and mark finish. While if it's not finished, even just one processes, and then the system potentially unsafe. Then here it will print the step by call print step method. And then for the next step, it will explain by my teammates. Thank you.
My name is Fathan Rasim Muhammad. My metric number 81EC4045. So I want to continue Faiza's explanation before. In here we have method display status. This method will print out all of the process and then all of the values of each process. The values are allocation, maximum allocation, need, and available. So we use for loop to 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 iterate all of the process. And then in here we have method is less or equal. This method will compare two factors, factor 1 and factor 2. If factor 1 is more than factor 2, so it will return false, and then if not, it will return true. And then we have factor add, this method to add two factor, factor 1 and factor 2. If uh, and then uh, the the result will be assigned in the variable result, and then this method will return the result. And then print step, this method will display and show uh, each uh, uh, each comparison of the process. So if um, if need is less the or equal to work, so the work will be added with the allocation of each process. And then in the display vector, this method will just display the value inside a vector. And lastly, in the main function, first we declare uh, the class resource manager with the system with the available value of 3, 3, and 2, and then in here we we add the process in the system. So this is the current allocation, and then this is the maximum allocation. So this is the display status. It will print out the value of allocation, maximum allocation, the um, maximum allocation, and then the and need and the available. And then here we have the conditional statement. If the system in safe state, so it will print out all of the comparison of each process, and then the system will print out this is the safe state. If not, it's not in the safe state. And I will show you the output. So this is the output. We have the information of all the process, and then we have the information of the comparison of each process of with the work. So like in the output, if the need is less than work, so it will print out uh, the allocation with the work. So the value of work is changed. So this is the last value of the work, which is 10, 5, and 7, and then the system said the system in a safe state. So that's all from us, and thank you.